Okay. So, gentlemen, we will continue with the discussions on signals. Last time we were discussing about impulse functions. A unit impulse will be denoting by delta t. This is a function whose value is 1 at t equal to 0 and equal to 0 otherwise, where this function is representing the force. So, this is from 0 minus to 0 plus, or you can write infinity, it really does not matter. That means, the function is coming here, its magnitude is very, very large and duration is very, very small, and then it is going, and this thick line represents something equivalent to this area, all right. So, the integral is finite. When this is 1, it is a unit impulse. Okay. This is time t and this is the function. We normally show it by an arrow and a vertical line. Impulse appears at this moment t equal to 0. So, delta t minus 3 represents what? This is a shifted version shifted version of the same impulse, that is at t equal to 3 this function appears. Okay. Similarly, what will be u t minus 4? It is the shifted version of unit step. Okay. U t minus 4 represents a function which starts after t equal to 4 or at t equal to 4. It is unity after that, before that it is 0. So, any function, if we shift f t is a function say like this, then what is f t minus tau? If I want to represent the same function which is starting after an interval tau, if it is identical, okay, then what will be the mathematical representation of this function? F t minus tau, does it represent this? F t minus tau represents this function on this side, all right, but what about this value? I want to show that this is 0 till that time. So, this has to be multiplied by u t minus tau. So, f t minus tau into u t minus tau represents this function. Okay. So, there is a finite delay of tau. So, e to the power minus 3 t, what is this function like? Exponentially decaying, okay, starting with 1. So, if I want to represent this same function which is shifted by 4 seconds, say, what should I write for this? E to the power minus 3 t minus 4 u t minus 4. Now, can you tell me, if I do not write this, what kind of function will it be? If I do not write this function, this also has a value here, is it not? So, My interest is to express this function which starts only after t equal to 4, but which is having an exponential decay rate given by this e to the power minus 3 t. So, in the time domain I will write e to the power minus 3 t minus 4 into u t minus 4. So, you will find this u function u t minus 4, t minus tau and so on, this be clubbed with this to represent a function which is starting after tau, after 4 seconds, and before that it is always 0. Okay. Now, tell me how I represent a pulse by continuous functions. Suppose this is 5 seconds, this is 10. What will be the representation of this in terms of known standard continuous functions? I can write this as sum of this function of magnitude 10 plus a function which is minus 10 after 5 seconds. Okay. So, what will be the mathematical form for this? 10 u t then minus 10 u t minus 5. Okay. So, this will be representing this function. Okay. Let us take a few more examples. What will be, suppose this is 20, this is 4 seconds. What will be the representation of this? Yes, 20 by 4, it is having a slope of 20 by 4 t. If I take 20 by 4 t, this will be a continuous function, but then it has to be interrupted at 4th second, that is at t equal to 4 it has to be brought down to 0. So, minus 20 by 4 into t represents this, that will be there. At t equal to 4 I have to add something to counter this, so that it is brought to 0. So, minus t minus 4, t minus 4 represents what? T minus 4 into u t minus 4, u t minus 4. Actually, with this t also I should have written u t. So, and what about 20 by 4 slope? There is no slope here, 20 by 4 is 5. So, 5 into t minus 4 u t minus 4, will that be all right? Let us see what it is. 20 by 4, that is 5 t, this is the first one, 5 t u t, okay, or 5 into r t, somebody may write 5 into r t ramp, plus minus 5 t minus 4 u t minus 4, all right. So, what will be the end product? This one? Will the end product be this one? All of you agree? Yes. Then anything else? What is it? See, this is going on increasing. After 5 seconds, you are applying a negative ramp of the same slope. So, the increment will be countered by the decrement. You are offsetting the increment by having a decrement at the same rate. What about the existing value? Then it will stay there at that value. You are subtracting the increment with the decrement, is it not? It is like this, you deposit every month 100 rupees in the bank. So, after 12 months, you deposit 100 rupees and your brother takes away 100 rupees, you are having a joint account, alright. So, your addition is offset by the subtraction, then how much is the money left in the bank all the time? It will be remaining at the 1200, in the first year you have accumulated 1200 rupees. So, it will be staying there at that constant value. So, here this plus this will not suffice, then plus you have to take out that 1200 rupees also, then only it will become 0. So, it will come to 0 value only when you are applying a negative step of magnitude how much? 20. Okay. So, 20 by 4 t into u t minus 5 into t minus 4 u t minus 4 minus 20 u t minus 4, that has to be applied at the same time. So, summation of these 3 will give you this. Is that all right? If I call it sum f1 t, that is simplified form 5 t u t minus 5 t minus 4 u t minus 4 minus 20 u t minus 4. Okay. What would be the representation of this? Suppose this is 2 seconds, this is 4 seconds and this is say 10. What would be the representation of this? This is having a slope of again 10 by 2, 5. So, f t will be 5 t u t, agreed, 5 t u t, that will be taking it along this line, but at t equal to 2 what do? I give a decrement. So, now tell me what should be this? Minus 5 t minus 2 u t minus 2, it is twice the slope because something was going up, you want to offset it by 5 t, then it will be coming to horizontal position, another 5 t will make it this way with a negative slope. So, minus 10 t minus 2 u t minus 2, will that be all right? So, this plus this, will that give me this or this will continue? Is it not? So, that has to be again offset by plus how much? Plus 10 t, because it was going up, then to bring it to this position you had given minus 10 t, is it not? Then again you have to turn it to that position, it has to be plus 10. I want to make it horizontal. If I give plus 10 t, what happens? Again it will start rising. Okay, I am coming to that in the next problem. So, here it will be plus 5 t minus 4 u t minus 4. Okay. Now, the next question is, suppose I have a triangular function which is repeated which is repeating and so on. So, what will be the expression for 0, 4, 8 and so on? This is 6, this is 2 and so on. So, what will be this? F t will be 5 t u t, okay, minus 10 t minus 2 u t minus 2, now plus 10 t minus 4 u t minus 4, very good, then minus how much? So, it is alternately plus 10 and minus 10 at an interval of 2 seconds. Okay. So, minus 10 t minus 6 u t minus 6 plus 10 t minus 8 and so on. So, generalize it u t minus 8 and so on. First one you keep aside 5 t u t, and after that minus 10 t minus 2, minus 10 t minus 6 and so on. So, minus 10 t minus, I can write 2, 6, 10, 14. So, t 2 plus 4n, n is an integer, u t minus 2 plus 4n, okay, where this summation n varying from 0 to infinity. So, n equal to 0, 1, 2, 3 and so on. Similarly, plus 10, again you put a sigma t minus 4n, t minus 4n, n varying from into u t minus 4n, n varying from 1 to not 0, 1, all right, 1 to infinity. Is that all right? Because the first one is 5 t u t. So, this will be the general expression for a periodic function. Similarly, if I have a pulse train, we are gradually going towards a periodic function, a pulse train of width tau and period t, t1, there are likely chances of confusing tau with t1 t. So, I am putting t1 and this is of magnitude say k, and it is appearing periodically. What will be the expression for this type of function, for this type of function? For the first pulse, what is the expression? K u t minus k u t minus tau. Okay. This is, if I call it f1 t, this is the first one. The same thing repeats after t1, t2, t2 is 2 t1 and so on. So, f t can be written as f1 t plus f1 t minus t1 into u t minus t1, okay, and so on. Into u t minus twice t1 and so on. So, it can be written as f1 t u t minus n t1. Is it f1 t or f1 t minus n t1? Yes, f1 t minus n t1 u t minus n t1 summated over n 0 to infinity. So, that represents a periodic function, and you can substitute for f1t this one. Okay. So, every time tau will also appear, okay, nt1 minus tau. Okay. When I incorporate this, one of the terms will be, this is having two components. So, you have to write like this. Another example I would like to take up. What is the representation of this function? 0, suppose this is 10 and this is say 10 seconds. This is a sinusoid, just 1/2 of a sinusoid, and that the function remains 0 after that. Okay. After half the cycle it remains 0. So, this can be written as, this portion is 10 sine twice pi by 10 t. Okay. Only this portion is following this. So, how do I write f t? If this is f t, if I write a function like this, then it will continue, but I am taking only one part of it. I have shown the expression for this, only this part, for this part, but actual function is like this, is it not? If I write like this only, then it will continue. Okay. So, what should be f t? 10 sine 2 pi by 10 t minus what? What do I subtract? 10 sine 2 pi by 10 t minus 10. Do I subtract? Into u. Do you all agree? Do you all agree? If I subtract this from here, what do I get? Every time you are having subtraction in your mind, whenever the function is terminated, all right, you are applying a negative function of the same magnitude and trying to offset the existing function and making it 0. But you see, this function is continuing like this. So, if I just add this function at this point, then that will be countering it. Basically, the delay is 10 seconds, all right. So, if I add this function itself, which is delayed by 10 seconds, the positive part will be countered by the negative part, all right. Here the negative sign will not come. Is that clear? Therefore, if I have a repeated function like this, what is it actually? Rectified full wave rectifier output, rectified sine wave. So, what will be the expression for this? The same magnitude, say 10, and was this all right? Yes, 10 by 2 pi by 20. Basically, this is not the period, this is the period 20. So, 2 pi by 20, 2 pi by 20. Okay. Now, suppose this is 10, 20, 30. Now, you tell me what will be f t like. What should I write? 10 first part sine 2 pi by 20 into t Mind you, for such functions, unless it is a delayed function, I am not writing ut. It is understood that we are not considering the negative part of time, so far as the first part is concerned. Otherwise, I should have, to be more precise, I should have written it multiplied by ut, the first one, okay. Then it will be precise, okay. It does not exist on this side either. So, t into ut. Now, what will be this function? What will be the representation? 2 pi by 20 t into ut is this one plus 20 sine 2 pi by 20 t minus 10 u t minus 10. What does it give me? If I add plus 20, then it will be this one, okay. Then again add. If I take this plus this, what happens? Let us draw and then see. This plus this gives me what? This one is 10 plus there is another sinusoid that I am adding after half the cycle of magnitude twice, okay, because of the space here I am. So, it is like this and so on. So, if I add this with this, what happens? It will be this, then minus 10 and plus 20. So, this will be plus 20, then after this point this is plus and this is minus 20. So, it will become, is not. So, at this point again I have to add plus 20 to cancel this as well as add another 10. Is that all right? So, plus 20 sine 2 pi by 20 t minus 20 u t minus 20, and by the similar logic you keep on adding 20 sine 2 pi by 20 t minus 30 t minus 40 u t minus 30 u t minus 40 and so on. So, the general term will be, if I now write this as 10 sine 2 pi by 20 t into u t plus 20 summation sine 2 pi by 20 t minus 10 n, where n is an integer varying from 1 to infinity, u t minus 10 n. Is that all right? U t minus 10 n. So, you know how to represent periodic functions, where the periodic function will be consisting of shifted versions of some continuous standard functions. If you have a trapezoid, what will be the representation of this function, or if it is a repetitive function like this. So, we will be interested in finding out first of all the first period and then keep on repeating. Okay. So, here it will be, if the slope is k, then k into t, all right. whatever be the slope, accordingly f t will be, suppose this magnitude is 100, this is 5, then it will be 100 by 5 20 t u t, is it not? It would have continued like this. So, at t equal to 5 we apply a negative slope of the same value, then it remains there. So, minus 20 t minus 5 u t minus 5. Now, I do not have to add anything else because I am not bringing it to 0 like the earlier case, it remains there. Then at this point, suppose this is 15 and this is 20, then minus, at this point I apply again a negative slope depending on the slope. Here I have put identical values, that is 15 to 20 is 5 seconds range, 0 to 5 was also 5 seconds. So, the slope will be same. So, it will be minus 20 t minus 15 u t minus 15, and then it would have continued like this. I can take this one block and then keep on repeating it, all right. If I do that, then at 20 I should bring it to 0. So, it was otherwise continuing. So, at 20 what should I do? Plus 20 t minus 20 u t minus 20. So, these 4 functions collectively will give me the first block. That means, the function remains constant after this. It goes like this and then remain constant at 0 value. If it remains constant at 0 value, then that will be giving me the first period. Now, you keep on repeating this. This is one approach. The other one is, at this point also I add twice the slope, again at this point I apply what? Minus 5 t, 20 t. Okay, let us write then. So, you are adding here 40, okay, 40 t. Then what will be the next? Plus or minus? Minus, should it be 40 or 20? See, the after adding 40 you are getting a net increment of 20. So, that 20 has to be offset. So, t minus 25 u t minus 25 and so on. So, you keep on writing further terms. So, this is the other approach. So, if you are adding 40 t here, that will be giving me an overall function of this kind. So, I have to bring it down only by 20 t, not by 40 t here. Okay. Sometimes you are given truncated sine waves. This is a kind of function you get in a capacitor discharge, capacitor charging and discharging circuit. If the discharge is very fast, this gives rise to basically the sawtooth function, is not sinusoid, basically exponentially increasing functions. Suppose these are part of sinusoids, that means one quadrant 90 degrees, 0 to 90 degrees we take. This is say in this form Vm sin omega t. Okay. This is a part of Vm sin omega t function, but then that is truncated and that is being repeated. What will be the function representation? So, up to this is t by 4, 1/4 of the time period. So, up to this t by 4, whatever be the time, it will be following this. So, let us get the representation of this. Suppose the original period is, suppose this is 5 seconds, this is 20, then it is 20 sine how much 2 pi by 20, because 4 times 5 will be the time period into t into ut. This is the first part, but then at 5, that is at t equal to 5, what do I add? 20, what do I add after t equal to 4? Let us see what we have to add. This is one function plus addition of what will give me this value 0 from this point onward. Okay. And what is this function? Cos, very good, cos 2 pi by 20 and then cos shifted by, am I all right by writing this? Should it be plus or minus? Cos 0 would have been plus, so it will be minus u t minus 5. That has given me only the first one, okay, and then you keep on repeating it with an interval of 5 seconds. The period is 5 seconds. Okay. So, if you can represent this as f1t as the first block, then the desired ft will be f1t plus f1t minus 5 into ut minus 5 plus f1t minus 10 ut minus 10 and so on. Okay. We shall be using this at a later stage when we use Laplace transform functions. Such repetitive functions, we will see how to take care of these for determining the Laplace transforms. For transients, for the transients in networks, we use Laplace transform very extensively. So, today I will just give you an introduction to Laplace transform. We shall take it up in greater detail in the next class. When you go for some kind of a transform, now transformations are required for simplification of certain computations. For example, when you take the products of two quantities, the quantities are to be multiplied, the computational rigor involved may be prohibitive. If you take logarithm, logarithm is basically transforming the quantity into a different domain, all right. Then the multiplication operation becomes very simple, you add there, and then you go for the inverse transformation, that is taking antilog, you get the product of the multiplication. So, in the normal algebraic operations A into B, which is equal to C, if you take in the transform domain, it becomes log A plus log B, which is equal to log C. So, in the transform domain you add them, the operations are also changing, multiplication becomes addition, and then after addition if you take inverse transform, you get back the original product. Similarly, in Laplace domain, what we do in transient analysis, you have seen you have differential equations governing inductance, capacitance, resistance, all other elements. in a circuit governing the dynamics of the system, they will have two types of solutions, complementary solution, particular integral. You also put the boundary conditions at the end to determine the coefficients, the constants. Now, all these can be computed in one go, that is, you get both the transient as well as the steady state solutions. You get all the constants also evaluated right in the beginning. You do not have to put it at the end, you can evaluate them right from the beginning. So, there is an advantage. You do all the computations together, and for higher order differential equations, especially when you have more than 2 or 3 variables, it becomes very difficult to solve differential equations. Suppose you are having number of loops and you have number of differential equations involving currents in different loops, voltage sources. So, all these can be simplified. A differential equation is transformed into an algebraic equation, by Laplace transform. So, in the transform domain, equations become very simple with simple algebraic variables like x, y. So, we use an operator S. So, it will be S, in terms of S you get all the equations, S is the variable, you solve for it, then you go for inverse transformation to get the solution in the time domain. This is the beauty of this transform. Now, by definition we write F s as the Laplace transform of the time domain function f t, okay, and this is given by a curly L f t, that is Laplace transform of the function f t is equal to f s. It is 0 minus to infinity f t e to the power minus s t into d t. We define the function like this. So, we will take from this very definition some of the very typical signals that are used in electrical circuits and determine their Laplace transform. Okay. Let us take a function e to the power minus alpha t as the function f t. What will be its Laplace transform? So, e to the power minus alpha t into e to the power minus s t dt 0 to infinity. When we write 0 minus, that means the function is taken only from t equal to 0, before that it is not existent, all right. So, we take up only those functions which exist only in the positive region of time. This is s plus alpha that will give me 1 by s plus alpha with a negative sign and e to the power minus s plus alpha into t 0 to infinity. At infinity this becomes 0, at 0 this becomes 1, since it is in the lower limit. So, that will be associated with a negative sign, negative and negative will become positive. So, it will be 1 by s plus alpha. Okay. Now, suppose alpha equal to 0, then e to the power minus alpha t that we are considering between 0 minus to infinity becomes u t, because we are considering only in that range. So, it becomes u t. So, what about the result? Put alpha equal to 0, that gives me 1 by s. Okay. Then let us differentiate e to the power minus alpha t with respect to alpha. So, e to the power minus alpha t has given me a transform of 1 by s plus alpha. Alpha is a common term, all right. So, let us differentiate with respect to alpha. The left hand side will be minus t into e to the power minus alpha t, and on this side it will be minus 1 by s plus alpha whole square. Minus goes out. So, t into e to the power minus alpha t will be having a transform 1 by s plus alpha whole square. Put t equal to 0. If I put t equal to alpha equal to 0, again in this case, then on this side it is t into ut. Ut is implied here, because we are always considering only the positive region of time. T into ut, that is the ramp function RT, its transform is 1 by s squared. Differentiate once again with respect to alpha. This will be t cubed, on this side it will be 2 by s cubed. So, if I differentiate n times, on this side and then make alpha equal to 0, differentiate this one n times and then at the end you put alpha equal to 0. On this side you have t to the power n, this side it will be factorial n by s to the power n plus 1. See, here it will be 2 by s cube next stage, then 2 into 3 by s to the power 4 and so on. Let us put alpha equal to a plus jb, okay. Then e to the power minus a plus jb into t will have a Laplace transform of 1 by s plus a plus jb. I have just replaced alpha by a plus jb, the first one. What is this? E to the power minus at cosine bt plus j sine bt. Okay. So, on this side if I separate out the real and imaginary parts, it will be s plus a by s plus a whole squared plus b squared minus jb by s plus a whole square plus b square. Equate the real parts and the imaginary parts, then e to the power minus at cosine bt will give me s plus a by s plus a whole squared plus b squared. E to the power minus at sine bt will be b by s plus a whole square plus b square. So, e to the power minus 18 into cosine bt is a damped sinusoid starting with a maximum value. This is e to the power minus 80 cosine bt. Similarly, e to the power minus 80 sine bt. It is like this: you take a pendulum, give it an oscillation, all right, give it a displacement and then let it oscillate. It will oscillate and die down, is it not? And you have a recorder, all right, you just record the image of this point, the bob, then it will be damped sinusoid. If you start your camera when it is in the maximum position, then it will be a cosine function. All right, you move the paper, it will be describing this. If you start from the central position, then it will be this one. Okay. So, both are representing basically a damped sinusoid. So, today we will stop here for today, we will continue with this in the next class. Good morning friends, we shall continue our discussions on Laplace transform. Yesterday we derived the transforms of some standard functions, we will continue with that. Before we go to the set of other properties, I just like to mention that a function f t is Laplace transformable if f t mod e to the power minus sigma t dt 0 to infinity is a finite quantity, that is it is less than infinity. Now, if you have a function say f t equal to say t squared or t cubed, will this property hold good for this f t? Let us see. F t into e to the power minus sigma t as t tends to infinity, how much is this product? T cubed into e to the power minus sigma t, okay, limit t tending to infinity. So, what will be the limit? I can always write this as e to the power sigma t, I can write as 1 by e to the power sigma t. So, 1 plus sigma t, 1 minus 1 plus sigma t plus sigma square t squared by factorial 2 and so on, and the t cubed on the numerator can be brought back here, it can be brought down here. So, this will be 1 by limit t tending to infinity 1 by t cubed plus sigma by t squared plus sigma squared by factorial 2 t, all right, like that, plus sigma cubed by factorial 3 t cubed will get cancelled, and after that you will get sigma 4 by factorial 4 t and so on. Okay. Now, how much is this coming to? One by t cubed, it will be 0, this will be 0, this will be 0, this will be finite. So, it will be equal to 1 by sigma cubed by factorial 3 plus this will be infinite terms multiplied by t. So, it will be equal to 0, this is limit t tending to infinity. So, this will be 0. So, a function now when t tends to 0, this is infinity, this is infinity, this is infinity, these are all zeros. So, 1 by infinity, that is again 0. So, what will this function look like? T cubed is a function which is going up like this, cubic parabola, all right, and t cubed into e to the power minus sigma t, e to the power minus sigma t is a function going like this. So, the product will be starting from 0 ending at 0. So, somewhere it may have a peak and then it will be going like this. So, the area will be finite, this is going to 0. So, area is finite. If you have a current expression, for example, current is, for example, in a capacitor 1 by c integral I dt 0 to t is the voltage at any instant. If I have to take the Laplace transform of this, given the Laplace transform of it as is, what will be Vs? Vs is integral of I, is it not? So, if I have to compute Vs, it will be 1 by c into integral of, this means original Laplace transform divided by s, then plus what? Is it I0? What is f0? It is integral of that. So, integral of I dt, okay, divided by s, and this is to be evaluated at 0. From where do we start? So, 0 minus to 0 plus, or basically whatever has been there before the counting of time, before t equal to 0. So, that gives me integral of I dt is what? Charge q, is it not? So, integral I dt means this is to be evaluated at t equal to 0, means the initial charge q naught, alright. Mind you, it is not initial value of I, initial value of integration of I. When you take the integration, so initial value of not f1, f naught means integration of f1, alright. If the initial condition is given as 0, then there is no problem. So, 1 by Cs into Is plus, if I call it Q naught by Cs. Q naught by C is nothing but initial voltage across the capacitor. So, V naught by S, evaluate at minus alpha k. Then AK2 will be derivative of this Qs and then evaluate at s equal to minus alpha k. Similarly, AK3 will be 1 by factorial 2 d square Qs by ds square, second derivative you take, and then substitute s equal to minus alpha k, and so on. Third derivative it will be factorial 3, and so on. So, you keep on taking the derivatives of this product and then evaluate the function at s equal to minus alpha k. That will give you successive residues. Once you know that, you can expand, you can find out the inverse. Okay. So, we will stop here for today. Thank you very much. You try some of the problems at home, and we will take up some numerical problems in the next class.